Okay, so by way of a little background, let me just point out something that's so obvious even Time Magazine is onto it, but there's been a dramatic change in a lot of the stuff that's happening on the web these days. So whereas 5 years ago or so, most of the stuff that you found on the web, or a lot of it, was professionally edited text. Newspapers, magazines, corporate stuff, academic prose, even amateur-produced sites often had sort of in rough outlines the pattern of a professionally produced site. People were writing texts for an anonymous audience. The author was taking the stance of an authority and producing things for a mass audience that shared relatively little context, perhaps, except a very general public context with the author. Now, much more of what happens on the web is interactive. We have blogs and wikis and discussion forums and chat rooms and social networking sites and things, where the point of the behavior on the web isn't to produce a text. The text is a byproduct. The main point of being on the web is the interaction, and the text is only a secondary thing. Now, there are, of course, big differences between chat rooms and wikis, but in a lot of cases, the real point of being on the web is serving more of a social function, and the text is just a secondary part of it. So this is obvious. What's maybe less obvious, though, is the consequences this has for natural language processing, working with web text. So for instance, this is maybe the sort of thing that sentiment analysis or question answering systems have been designed to deal with, something like this. So this is an editorial from a small-town Texas newspaper. We know it's an editorial because it says editorial at the top in boldface, right? And what's it about? It's about minimum wage. We know that because it says minimum wage at the top. We know who's responsible for it, the editors of the Lufkin Daily News. We can track down what the Lufkin Daily News is. It's a small-town newspaper. We know something about that. We know what editors are. We know what editorials are. We got a date here. And then the article, the editorial, sets off to construct an argument about the minimum wage. It has several paragraphs. The first paragraph presents a bunch of facts, right? Things like the minimum wage has been set at $15 an hour since 1997, right? And there's this chain of facts which are put forth to construct an argument about the minimum wage. Now, it's not that false things never get printed in newspapers, but for the most part, we can assume that an editorial in a newspaper won't print a bald-faced, easily verified lie, right? If they say that the minimum wage has been set at $5.15 an hour since 1997, that's probably true, right? And the article follows kind of a stereotype structure of constructing this argument that the minimum wage should be raised. Now we can compare that to discussions about the minimum wage on online sites devoted to political debates. All right, so here are 4 posts that I pulled out from a discussion of the minimum wage. Each one of them is constructing an argument that, at least in context, can be interpreted as an argument about whether or not the minimum wage should be raised. But the kinds of techniques that we could use for analyzing the arguments in that editorial are not going to work very well for these kinds of texts. For one thing, we have no idea who the authors are. Right? We know that the authors of the editorial are the editors of a newspaper. We don't know who these people are. Right? They could be political science professors. They could be lunatics using a public terminal in a library. They may be 8 years old. They may all be the same person. We have no idea of that kind of background of what they are. So in the first one, we've got somebody saying, if inflation won't happen with minimum wage increases, then why not put minimum wage to $100 an hour? Well, that has the form of an argument for raising the minimum wage, but of course we'd interpret that as an argument against raising the minimum wage, right? He's making this sarcastic claim that raising the minimum wage won't have any negative consequences. And then there's all kinds of idiosyncratic stuff in there. You've got these webisms like LOL, you got the $ after the 100 there, affect prices, right? There are these little kinds of things in there that you wouldn't find in professionally edited text, right? They're kind of irregularities. The next one, what's the matter, Rockhead? You don't want to help the poor, needy people? You rich bastard Kool-Aid drinker. So Rockhead here is the screen name of one of the participants. Right? So this is being directed to one of the other participants. In context, I think what's going on here is that this person, by parodying the kind of argument you might make against Rockhead, in Rockhead's defense of keeping the minimum wage low, he is in fact defending Rockhead in the community. right? But that's not at all obvious from what's being said, right? You have to kind of interpret that based on the context. The next one, that was pretty stupid, man, honestly, grow up. Well, this is a pointed argument against one of the other participants, but unless you know what the context is, you have really no idea what this person is saying. They're either making an argument in favor of raising the minimum wage or lowering it, but you have to know what this is a response to. And you can't tell just from looking at the post what it is a response to. Right? You have to really know something about the community and the structure of the debate. And then the next one, I don't have a kid brother, and that's the entirety of the post. I originally pulled out as an example of a complete non sequitur, although it turns out it's not a non sequitur. Much earlier in the thread about the minimum wage, someone had constructed this argument that suppose you're working in a convenience store and you've been working there for 5 years and you've worked your way up to $9 an hour, and then your kid brother starts working there at minimum wage. They raise the minimum wage, so his wages now are much closer to yours. You're going to be pretty irritated that all that seniority has been lost, right? The wage compression at the bottom is going to make you unhappy. And this guy, by saying, I don't have a kid brother, is refusing to even participate in the hypothetical situation that this person is debating about. So there is a rhetorical point to what he's saying here, but you really have to have a idea of what the structure of the debate is and what the community structure is in order to make sense of this. Simply looking at, I don't have a kid brother, isn't going to tell you very much of anything. Unlike looking at the editorial from the Lufkin Daily News, you can see what the structure of an argument for raising the minimum wage would look like. Right? Now, it's not to say that there's no information in these transcripts. Right? There's, in fact, a lot of information. And for one thing, you get a record of the kinds of informal interactions that are going on. Right? It's as if you had bugged a bar or something. You could listen to informal public conversations, and yet the information is all there available for us. Individual posts have very little information in them. Right? You can't look at a single post like, I don't have a kid brother, and make any sense of it. But if you have thousands or millions of those posts and their context, then you can start to get somewhere with it. There are all sorts of applications for this. One obvious one is in marketing, right? Using data mined from these sorts of discussions as an alternative to, something in addition to more conventional market research work, like polls and surveys and focus groups, right? So you can go out and look at these sorts of texts and see what's going on. What are the issues that people are talking about? What are the rumors that are going around? What do people care about? And you can get kinds of information that you couldn't get any other way, but you can't really do it manually. You can't really have, I guess you can, but it's probably not cost effective to have marketers reading through millions and millions of posts to try to figure out what's going on. You really need some sort of a statistical lever to get into this data to draw summaries of it. Right, and most of the work that I've done in this area has been in two domains, looking at informal political discussions and also looking at discussions of pharmaceuticals for pharmaceutical marketing. And it occurs to me that there's a kind of an interesting parallel between these. These are two areas where you might think marketing would have no place. Right? You should be able to decide who you're going to vote for or which medication you're going to take on purely rational grounds. And an advertisement shouldn't make any difference. Right? A politician is either going to defend your interest or they're not. But yet there's a huge amount of money spent on marketing in both of these areas, and it seems that marketing is very important. And yet it's hard to measure exactly what the impact of the marketing is in these areas. All right, so one challenge, though, to using this sort of data for market research is that the population who participates in these sort of things is by no means a random sample of the population. Right? If you look at informal political discussions, these are people who have chosen to spend their time arguing about politics with strangers online. That's not, I hope, the typical person. Right? It tends to be a young male, either politically extreme or kind of playing politically extreme person. For pharmaceutical research, looking at people who participate in online sites for people who suffer from various medical conditions, they tend to be people who are newly diagnosed or have suffered some sort of a relapse or a worsening of their condition or something like that. People rarely post to a support group saying, I've had this disease for 30 years, but it's completely controlled by my medication and I don't even think about it. Why would they post that, right? They're off living their lives. It's only if they have a problem that they come to participate in one of these sites. So you can't just say, well, 40% of the people on some site think George Bush is an idiot, because you don't know anything about what those people are. But if you could segment those people, if you could say, well, these participants, these people who are posting, they seem to be extreme conservatives, right? Yet they don't agree with some of George Bush's policies. Well, that could be an interesting fact, because now you know something about what kinds of people those are, and you can associate that with an opinion that's being expressed. Or you could say that these are people who are newly diagnosed with a condition, and these are the concerns they have. Or these are people whose children have just been diagnosed with a condition, and these are the things they're asking about. That's an interesting fact, but you can't really say something that, well, 35% of the people on this site are worried about generic medications. Well, you don't really know who those people are. So an important first step for doing this, any sort of work with this, is to try to figure out who these people are, to do some sort of broad demographic classification people, guessing their age or their gender or their disease status, right? Whether they are newly diagnosed with a disease or whether, say, they're a caregiver of someone who's newly diagnosed, or perhaps their political orientation in a political site. So the experiments I'll talk about today are aimed at trying to guess the political orientation of participants in informal online political discussions. And this is from a data set collected with Tony Mullen from the politics.com site. So we have about 5.5 million words of posts collected from this site over about a 6-month period, I think. There are 408 distinct users that showed up in this data set. Most of those users, in signing up for this site, gave themselves a self-political description. So they gave themselves a label, right, which we can then use to see if we can predict what that label is from the content of their posts. Right, so we have an idea of what they at least describe themselves as politically. Of those 408 users, 19% of them posted exactly once during our sample period. Right? And the most prolific poster was responsible for 6,800 posts, or almost 10% of the entire sample was one guy. The second most prolific poster had about half that number. And in fact, this is the same pattern I've seen in every single online discussion. If you get one of these, right, for posting distribution, right, you get this sort of, the same sorts of problems that Zipf's law gives us for any sort of lexical analysis. We get the same thing here. We get a huge number of posters where we have very little data about, and a small number of posters who seem to really overwhelm the discussion. I don't really know why. Right? These sites that I've looked at have really different social character, and yet they all have this in common. There's perhaps different reasons why this happens in different sites. But anyone who's ever participated in any sort of online discussion knows that there are always a few people who feel compelled to respond to everything, even if the response is, I don't know, I've never thought about that before. And those seem to be the people who really kind of dominate the number of posts and also are very important in determining what the character of the discussion is. Okay, so here's a breakdown of the political orientations that we've got. People could describe themselves politically any way they want. It wasn't a multiple choice question. So what we did was we took their self-descriptions and classified them in various ways, to say Republican or conservative or right fringe, centrists and independents, Democrats, liberals, left fringe, libertarians, Greens, and then people who either chose not to give an affiliation or gave an affiliation like Martian that we couldn't really make any sense of. Right? And then for things, these are fairly fine-grained classifications. We also sort of bucketed these into right, center, left, and then people who don't really quite fit into the right, center, left pattern. And in the experiments I'll talk about today, we focus just on right and left. Right? By looking at somebody's posts, can we tell whether their self-political description would be right or left? Right? So, one way to proceed with this is to consider it like a kind of sentiment analysis. Right? And sentiment analysis is a very simple one-dimensional summary of a text or a collection of texts, usually trying to say looking at product descriptions or product reviews and trying to decide whether the general discussion about this product is positive or whether it's negative. Right? Do we get a thumbs up or a thumbs down on it? So this is a very simple semantic representation. Right? It's basically just positive or negative in a single dimension. And there are various ways of doing this, but probably the most influential is based on Turney's work on what he called a PMI-IR method. So in this method, what you do is you take the text you're trying to classify, tag it, get part of speech tags for it, and extract all the noun phrases, and then identify the semantic orientation of each of those noun phrases by searching for that noun phrase in a large collection of text, like the web, for instance, and then looking for whether that target phrase occurs in the immediate vicinity of the word excellent or the word poor. So you look for the association between the words you're interested in and excellent and poor, and you can use point-wise mutual information for measuring that association. Right, so the point-wise mutual information is it's an information theoretic measure of the association between two things, right? Whether the joint probability of the target phrase and the word excellent, how close that is to the predicted probability you would get if they're actually independent, right? If there's no association between the two of them. So if the point-wise mutual information between a target phrase and excellent is high, positive, that means excellent occurs with that phrase more often than you'd expect, just given the raw frequency of excellent and the phrase. And the same with poor. And then the semantic orientation is the point-wise mutual information with excellent minus the point-wise mutual information with poor. So if a word occurs or a target phrase occurs with excellent much more than you'd expect and poor much less than you'd expect, you're going to have a strongly positive semantic orientation. If it's about the same, right, strongly positive with both excellent and poor, or kind of neutral with either, you'll get a neutral or orientation or close to zero. And if it's much more frequent with poor than you'd expect, but not with excellent, you'll get a negative semantic orientation. So from some of Turney's experiments, here are just some examples. Looking at bank reviews, direct deposit has a weakly positive semantic orientation. Unethical practices has a strongly negative semantic orientation. You can take all of the target phrases in a review, average the semantic orientations, and you get a picture of the semantic orientation of the entire text. Right? And in Turney's experiments, he got an accuracy of 75% more or less in guessing the semantic orientation of a text, although it varied a lot across domains. Some domains, like looking at cars, was much more accurate. Looking at movies was much less accurate. Right? One possible reason is just tastes differ a lot more, and so what counts as, everyone would agree unethical practices is a bad thing in a bank. Massive explosions, it's a bad thing in a car. Maybe it's a good thing in a movie, maybe it's not. It depends on your taste. And so the 60% accuracies were more in the domains where taste mattered more. Okay, so we could try to apply the same sorts of things to the political texts, right? The semantic orientation, this method, is giving us a positive or negative orientation because of the choice of the anchors, excellent and poor. Really, though, we could use this method for doing any sort of one-dimensional classification of texts, right? So by using different anchor terms, we could get a different cline of sentiment. So we could look, say, at liberal and conservative as our anchor terms, right? To get the dimensions we're looking on, use the exact same method to get a semantic orientation along that scale, right? So I tried that. I didn't use the entire web for it, but I used the 200 million word Reuters news corpus, right? So there's a lot of political discussion in that. The words liberal and conservative occur fairly often in there. From the online discussion forum text, I extracted about 170,000 noun phrases. So these are target noun phrases that may have a semantic orientation. And of those, about 5,000 of them actually did occur in construction with conservative or liberal in the reference corpus, so I was able to get a semantic orientation for them. And if you look at the results that come out, some of them make sense. Now, they don't all make sense, right? I selected some here that make sense. There's a lot of noise in it, but there's also something happening here. Right? So on this scale, liberal is positive and conservative is negative. So you get things like Jerry Falwell or Bill Kristol, the American Enterprise Institute, far rightist. These are things that are turning up with a strong conservative semantic orientation. Things like condom use or the Economic Policy Institute, these are showing up with a strong liberal semantic orientation. So something is happening. Oh, there is some noise in it. We're not getting completely random results out of it. Okay, so going back to the political text, there were 184 users who fell either strongly into the left camp or strongly into the right camp. And they're roughly equally split between left and right. So if we just call them all left, we get about 52% accuracy, right? Because 52% of them are actually left. some informal human ceiling kinds of experiments. Basically, I just performed this task of trying to classify users looking only at the content of their posts. I was right 87.5% of the time. I'm going to try to improve that number some, or make it more reliable. I'll get a couple other people to annotate the data, but at least as a first pass, it gives you an idea of roughly how difficult it is, right? There are some people who post once, and that post contains no political content at all, and man or machine, there's no way of knowing what their orientation is. And so this gives you an idea of what the upper bound is. This PMI-IR method, applied just the way I described it, gives us an accuracy of 40.76%, which is substantially worse than the baseline. It's not actually significantly different from the baseline, not quite significantly different. Of course, if you've got a binary classification and you're wrong worse than guessing, you can always just reverse the score, right? If the system comes up left, we'll say right, and then we'd be right 60% of the time. We still wouldn't be significantly different from the baseline, and we'll come back to this. There's actually a reason why that's not such a crazy thing to do, right? There's an intuition behind that, which we'll see in a minute. But some other possible problems with this, well, I used the Reuters corpus as the reference corpus and not anything else. Turney's experiments were based on counts that he got from the web. And so he was looking at a corpus that was many orders of magnitude larger than my dinky little 200 million word corpus. So that's a problem, right? It could be that the reference corpus was just too small. It's edited text. It's not informal text. And so it's going to have differences from the text I'm looking at. It was collected in the late 90s, so a lot of the political issues have changed. Some of the figures are the same, but some aren't. In the Reuters corpus, there's a lot of stuff about democratic majorities, right? Well, that wasn't true in the say 2005 when we collected this data. Things had changed, right? So there are some problems there, but also I think a key problem here is just that political orientation isn't a sentiment, right? And this method, which is designed to extract sentiments, isn't getting at what we want to get at here. Political orientation maybe is a bundle of sentiments. It's maybe a collection of sentiments, although looking at the texts, the sentiment that's most expressed most strongly is "you're wrong," more than anything about things in the world, right? The structure of the discussion is a debate. There's a lot of invective. There's a lot of strong sentiments being expressed, but they're not the kinds of sentiments that you get in a newspaper editorial, where someone is constructing an argument about some issue in the world, which then can be fit into the political spectrum. Okay, so it looks like sentiment analysis, at least this simple PMI-IR method, isn't going to quite do it for us. Well, another way we could tackle this problem is as a kind of text classification task. Right? So we can take these texts and apply any of the standard machine learning methods we have for text classification, like, for instance, naive Bayes to it, and see what we get. Right? If you remember, the baseline was 52.17%. Applying naive Bayes to it, trying to predict the political orientation of the author based on just lexical frequencies in the text, gets a 63.59% accuracy, which is better than the baseline and is statistically significantly different from the baseline. It is an improvement, but it's really not very good. Right? You might expect naive Bayes to give a better result than that. I also tried using support vector machines and didn't get anything significantly different from this. I imagine with enough tinkering I could improve over this, but not by a whole lot. Right? Looks like treating this as a text classification problem sort of works, but doesn't quite work. Doesn't quite get us what we want. Yep.
So, naive Bayes, what labeling does it use? Is this the manual labeling that you did?
No, it uses the self-description of the users, yeah. So some reasons why naive Bayes might not work. One problem is there are a lot of spelling errors in this text. So any sort of method that is lexically based, and like naive Bayes, which treats words as either same or different, the idiosyncrasies in the spelling are going to greatly increase the sparseness of any lexical counts. So there's a possible issue. Another possible issue is a big source of data sparseness is just the skewed posting frequency distribution. Right? We've got posters where we have hundreds of thousands of words that they've produced. We can probably guess their political orientation. Someone who only posted 8 words, probably no method is going to work for them. And so it could be that we're getting that tail all wrong. The sparse posters we're getting wrong, but we're actually doing a good job on the more frequent posters where we have substantial amounts of text for them. Yep.
So this test data is a number of users, right? Not posts.
Users, yes.
Then the tail shouldn't affect that.
Well, 20% of the users have one post, and so they have a small amount of text. So if we got all of them wrong.
Right, but what's your training and test split here?
It's fivefold cross-validation. So a 20%, 80% split, then across fivefold.
Okay.
Do you know what the accuracy would be if you do a cutoff on the test?
Yeah, I'll get to that in just a second. Yeah. Another possible issue, though, here is that the vocabulary that's being used by posters to talk about issues is actually the same regardless of what their stance towards that issue is, right? And then any sort of lexically based method, which is just looking for words to indicate orientation, aren't going to work very well. They're not going to be able to connect opinions to issues which we could use to get a political affiliation. So the spelling issue, we could test that. So here's an example of a post. The person is producing a perfectly reasonable argument. I mean, sort of maybe facile, but they're producing a political statement here, but their spelling is all over the place, right? And so any sort of method which is looking for key words in here isn't necessarily going to recognize Gutamano as the name of the base in Cuba, right? And so it won't be able to correctly associate this argument with what it's about. So as a simple test for that, I tried taking ASpell, an open source spelling checker, augmented its dictionary with some online terms, some online jargon, and some political terms taken from a collection of op-ed pieces. So this is professionally edited text about politics, so we can add some names and jargon and stuff to it. And applied that to the database of posts and then redid naive Bayes, and the accuracy actually drops substantially. We drop from 63% or so to 58%, which is a significant reduction. So not only doesn't fixing the spelling help, it actually makes things quite a bit worse. A couple of reasons why that might be. One is some of the spelling errors are not actually errors, right? And this is something that comes up quite a bit in these sorts of discussions. So here we've got, sounds like typical Democrat tripe to me. So tripe here is just plain misspelled. Democrat is not misspelled. He meant to say Democrat. And in fact, that is a very clear indicator of what this author's political orientation is. That's a very useful piece of information there. If somebody says Democrat, they're probably on the right. And we don't really want a spelling checker to come through and replace all those P's with T's. There's also a lot of this sort of stuff going on with names, right? People's names are being deliberately misspelled as a way to mock them, which then indicates very clearly what the political orientation of the author is. So sometimes these misspellings are actually extremely informative, and we don't want to gloss them over. Another problem is that these texts are just really it's hard to correct the spelling. And so the post that I showed before, this is what ASpell does to it. It does identify lots of misspelled words, but it doesn't actually correctly identify the correctly spelled word for any of them. Right? And in fact, it goes from a text which, although it has lots of misspellings, makes sense, to something that's almost got kind of a Dada quality about it. Right? Parishioners, real eased, they're all indecent. Right? It doesn't make any sense at all. So it may be that there's something to be gained from doing some kinds of spelling correction or some sort of normalization of that so that lexically based methods would do better. But it doesn't look like it's the irregularity in the spelling that's really what's causing naive Bayes not to work in this case. The other problem, data sparseness, looking at the distribution of posters, we could try repeating the experiments, but only evaluating the results on posters for whom we have a fair amount of text for. So we could limit ourselves just to those posters with more than 500 words. So people who just posted a URL and that's it, right? We won't try to classify them using naive Bayes. There are 100 of them. The baseline for this subset is 53%, and I got 91% of them right when I tried to classify them. Naive Bayes now gets a 67%, which is higher than what we got on the whole data set, but that didn't solve the problem, right? We're still getting sort of lackluster results here. Adding spelling correction to this gives us sort of a similar reduction in quality, 64%. So looking at just people who post more frequently does help some, right? The sparseness of the data for the infrequent posters is part of the problem. There's sort of good news and bad news about that. Of course, increasing the size of the sample isn't going to reduce the number of posters who we have very little data for. In fact, it'll increase the number of posters that we have little data for. The percentage of posters who post once will remain about the same, but we're not going to just be able to double our sample period and solve this sparse data problem. Now, sometimes, though, depending on what we're up to, we may only care about the people who post fairly often. Right? We may be interested in what are the core members of the group talking about, what are the sort of long-term, how do debates evolve over time. There may be questions that we want to answer for which getting accurate results about that tail just aren't very important. So there may be realistic applications where doing this sort of a cutoff or even raising the cutoff would be a sensible thing to do. Right? But I think really the key problem here, the underlying difference, or the underlying reason why naive Bayes doesn't really work is really that the vocabulary around issues is kind of neutral with respect to your orientation towards it most of the time, right? There are things like Democrat, right, where it really indicates what the person's orientation is, but for the most part, people call minimum wage, whether they think it should be raised or lowered or abolished or whatever, right? They call it minimum wage. So just to kind of look at what some of the terms are that are used by people on the left or the right, I tried using pointwise mutual information again to extract terms which are most strongly associated with authors who have a particular association, right? So the top terms for people on the left, the number one term is Bush. Number two term is Iraq, right? And going down, we get administration, American president, security, war, report. Dixie is one of the participants. He's actually the heaviest poster on the site. He's on the right, you might imagine. George, Americans, intelligence, staff, told. Right? These are the terms that people on the left are talking about. If you look on the right, well, there's some noise there, some HTML entities in there that didn't get filtered out when we were cleaning up the data that particular users on the right had in their signature file. So they showed up a lot. That's spurious. SR is a username, another one of the participants, where we get weapons, Saddam, liberals. Main man is another discussion participant. Liberal, Democrat, Bill Clinton, Democrats, understand, as in what you don't understand is. These are the sorts of terms that people on the right are using. Right? So it gives you kind of an idea of what the debates are like. People on the left are talking about George Bush. People on the right are talking about Bill Clinton. Remember the sentiment analysis results we got before. Users who use terms which were more closely associated with conservative in the Reuters corpus tended, not quite significantly, but slightly, to be on the left. And users who used terms which were associated with conservative in the Reuters corpus tended to be on the, did I get this backwards? Users who used conservative terms were on the left. Users who used liberal terms were on the right. Right? So for the most part, people were saying why the other guy was wrong. And they were bringing up things that could be used to structure these debates. So that's maybe one reason why reversing the answer you get out of the PMI-IR method isn't a crazy thing to do, that there may actually be that it's getting at something there. So that sort of points to a direction where we could go with this. Right? The debates have a particular structure. People are arguing with each other. And we can use that fact to try to get an idea of where a participant fits into the structure of the debate. And try to use that to guess what their political orientation is. This is something that people have looked at. Miles Efron used a version of Turney's PMI-IR method for guessing the political orientation of bloggers. And he used the links between bloggers as a way of augmenting the lexical data that he got from them. So he found that overwhelmingly, and he and others have found that overwhelmingly, bloggers tend to link to like-minded bloggers. You get these tightly knit communities of people who agree. And you can use those links as something in addition to the text in the blogs to try to guess which camp somebody falls into. Other researchers at IBM looked at Usenet posts which have a character that's more like the data that I'm looking at here to try to fit people into camps. In these discussion groups, the structure of the debates is a little bit harder to pull out. You don't normally get explicit URLs linking to another post or another participant in the site. Sometimes you do get URLs linking to newspaper articles or things where people are bringing in. You also don't necessarily get, as you would get in Usenet, these kind of tree-structured threads where you can see exactly what somebody is responding to. But you do get a little bit of that. You do get people quoting other posts, the bits of posts that they're responding to, right? And this is a device that users have developed for themselves for maintaining some kind of discourse coherence in these debates, where you've got long threads going on with lots and lots of parallel discussions happening at once, with people moving from one to the other. The only way that the users can make sense of it is by explicitly citing pieces of other posts. Right? So you get lots of this kind of stuff, right? Where here somebody is quoting what MBL 727 said and then responding to it. And so we can see now that this person is directly responding to an issue that MBL 727 raised. And we know now something about the context of what this person is saying. That's a response to this previous claim, right? Now, if you look at these citation links, so for each user, you look at the other users that they have quoted in their posts, we find that out of 41,000 posts, which were either by left or right users, about 4,600 of them cite another post by someone who is either on the left or the right, right? And overwhelmingly, 71% of time for people on the left and 82% of the time for people on the right, that cited post is by someone with the opposite political orientation, right? So what we can do is try to use this citation graph of who people have cited and who people have been cited by to try to fit somebody into the community, to see the kind of role they're taking in the debates. And here's the hypothesis is that users that kind of fill a similar role in the debate, that are responding to similar kinds of people, probably have the same political orientation. And we can try to use that as a way of getting into the data to try to figure out where people fit into it. So the algorithm I used here is very simple. Construct an adjacency matrix for this graph of co-citations, right? So a row in the matrix would be for one of the users, and each value in the vector would be the number of times that person has either quoted or been quoted by one of the other users, right? So we get this structure. There's a lot of noise in that, so I reduce the dimensionality of it using singular value decomposition to take just those singular vectors that had a singular value greater than 1. So we sort of compress the data a little bit. It works if you don't do this, but you get slightly better results with a little bit of analysis like that. And then that creates a citation space, and we can measure the distance between any two users by the cosine of the angle between their two user vectors, right? Very simple. We get a distance metric there, and we can then cluster users based on their representations in this citation space. Users who have quoted or been quoted by roughly the same cast of opposite characters probably are similar in their orientation as well. So I used hierarchical complete linkage clustering. So we get a picture like this. This is a little piece of the data, and then cut that off at a level that was determined by cross-validation and take all the clusters that have a diameter smaller than, in this case, 0.2. Right, so we get these guys here, these guys up here have citation behavior that's similar enough that we want to guess that they all have the same orientation. Right, in this case, they do all have the same orientation. They don't always. This method sometimes makes mistakes, but for the most part, we can pick out groups of users who are on the same team. Now, it would be nice if, when we constructed this citation graph, we got this nice bipartite graph where there was left and then there was right, and we could divide it right down the middle. It doesn't quite work that way, in part because there are a lot of different issues being discussed, and even someone who is generally on the right, say, may occasionally express a leftist idea. Or sometimes you get someone who is on the right who is making a very extreme claim, and other people on the right will say, well, that's nonsense, right? What you're saying is foolish, even though they basically agree with them on a lot of issues. So You don't get a nice division into two teams. The debates are much too complicated for that. But you can get sort of groups of people who seem to be playing the same role in the debates. All right, so then the next thing we did was to take all of the users who fell into a single team, group them together, and apply naive Bayes to them as a batch. Right? So now we've got a lot more text about them. The chances that they're going to use one of those terms that clearly identifies what their orientation is, that some member in the team is going to say something like Democrat, which clearly indicates what the orientation of the entire team is, goes up. Right? And so if you remember, the baseline classifier gave us 52% accuracy. Naive Bayes raises that to 63% accuracy. Applying naive Bayes to the output of clustering now gives us 68.48% accuracy. So it is an improvement over raw naive Bayes on individual users. Right? Something is going on here. And if we look at just the heavy posters, people who post more than 500 words, the chances that they're actually going to cite somebody else, and so this is that we're going to be able to cluster them, goes way up, and now our accuracy increases to 73%, which is still not maybe as high as we'd like, but we're actually getting somewhere now towards the 87% or whatever that the human ceiling was.
So you mentioned earlier on that the people who cite each other might be of opposite orientation, right?
Overwhelmingly,
so,
yeah.
Overwhelmingly. So how do you take that account in the citation?
I don't.
You
Right?
don't?
No. And so because well, right. So people. I also tried methods that directly took that into account. So we could say that, if we know what everybody else's orientation is, and we're trying to guess what this person's orientation is, we could say, well, they have the opposite orientation of whatever the majority orientation of their sites are. And that actually works pretty well. It gets us, if I remember right, it was in the mid-70s, the accuracy of that. So it's not that much better than this because the complexity of the debates is so high. Right, that it's not completely polarized between left and right. So this method, the clustering method I'm using here, if it turned out that citations were always across the political divide, then this should be able to discover that. But it's also flexible enough to kind of pick up that there may be several different issues, and one person may be on the left for 8 of those issues, but kind of pattering with the right for one of them, and it will fall out from the clustering. Right, that's the hope.
Was the graph that you showed, the picture that you showed, was it not representative enough? Because it looked like the co-citations belong to the same orientation. Is that getting it wrong?
So these are people whose co-citation patterns are similar.
Oh, okay.
But they may actually be all citing people who are in some other cluster.
Okay,
right? So,
thank you.
okay, so this seems to be getting somewhere, right? By taking the lexical content of what people are posting and then adding to that information about where they fit into the community, we can do better than we could just by looking at the text of their posts. By way of a little error analysis, this graph shows, so the points across the bottom are people that this method gets right. The points across the top are people that it gets wrong. Red cells are people on the right. Blue cells are people on the left, and the horizontal axis here, it's a log scale of the number of words that we have in all of their posts. And I don't know if you can see it clearly, but the people we're getting wrong tend to be sort of down at the lower posting density level. So they're people who we have less text for, we tend to get wrong more often. But there is this kind of interesting thing happening here in the upper right-hand corner. There are a bunch of users for which we have tens of thousands of words of posts that we're getting wrong, and they're all on the right. And I don't know why. This is sort of a puzzle that's left. But you can see that those dots there on the upper right-hand corner, they're all red. In fact, Dixie, the person who posts the most, and is in fact incredibly polarizing, and is far to the right on every issue, we get wrong. One possible reason for that is that this guy is so far on the right that even people on the right argue against him, right? Because he's so far out there that everybody's saying, Dixie, you're an idiot. That's the structure of a lot of these things. So it could be that he's such an outlier that he doesn't really fit into the scale at all. I don't think that's the full explanation of what's going on here. I don't really know what's going on. This is sort of an area that for future research. Other directions we could go to try to resolve the stuff in the upper left-hand corner, users in both the left and the right that we have moderate amounts of text for, 1,000 or 10,000 words of text. We ought to be able to classify them, and we're not getting them right. Directions I'm looking at, there are lots of technical tweaks I could use, right? Naive Bayes is not the best text classification algorithm out there. Clustering could certainly be improved. There are all sorts of ways that the algorithm could just be sort of tightened up that would probably give small improvements, but I wouldn't expect a substantial improvement from any of those. Could also try improving link detection. So right now, I'm only putting a link between two users if they actually quoted text from the other user's posts. But there are other devices that authors have for establishing relationships between posts and for maintaining coherence in these debates. So there are lots of vocatives, right? Main man is one of the participants, and you get things like, main man, it was Strom's birthday party. This is clearly a response to something main man said, although it's not actually quoting what main man said. So it could be that we could establish a link between this poster and main man. If we just do that, right? If every time somebody mentions another user's name, we create a link between those two users, the accuracy goes way down. So there has to be some classification of vocatives into ones that are useful and ones that are not useful. There's also perhaps something we can get from the thread structure. Sometimes if two posts are close enough to each other that the context of the previous post is still active, then a user won't have to quote what was being said because it's clear from what's seen on the screen what the relationship is. Again, simply making a link between each post and the previous post in the thread doesn't work. That's much too general. But there may be some way of establishing which posts are actually responding to earlier posts without actually quoting them. So that would increase the density of this co-citation graph and ought to increase the quality of the clustering. And finally, something that came out to me when I was doing the classification manually, most of the time the way I was able to guess what somebody's orientation was not by the stance they took on any particular issue, but by some sort of explicit linguistic expression of their group membership. Something like, it's very sad you conservatives can't win arguments on your own merit, you have to go petty and clone us liberals. Now you don't have to know what this guy's talking about to know that he has just outed himself as a liberal. He's just marked himself as a liberal. And looking at what arguments he's actually got or who he's arguing with is not nearly as helpful as the fact that you conservatives is something that only liberals say, and us liberals is something only liberals say. And you get some of that kind of stuff. In these things, there's subtler things. Sometimes people come out right and say, the reason I am a Democrat is, right? Well, that person's on the left, right? If you can find those sorts of things. Or, I used to be a conservative until, right? And then you can see that, well, they've transitioned from being on the right to being on the left. There are these sorts of things, more subtle things. Sometimes people will say, every time I hear some public figure say something, I cringe. Right? Maybe someone on the right is embarrassed by people on the right who publicly deny the reality of evolution, for instance. Right? So that's an indicator that the speaker is identifying themselves as on the right, but it's much more subtle than that, than just coming out and saying they're on the right. That's sort of the direction that I think this ought to go, into a deeper linguistic analysis of what's in the text, but not looking at the issues that are being discussed or the opinions that are being expressed, but for these sorts of markers of group membership. That's going to be the best way to do this kind of classification. All right, so it's just a summary of the numbers of each of the experiments. Right, you can see, so clustering with naive Bayes definitely does the best, although it hasn't completely closed the gap. Right, the human ceiling is still, I did quite a bit better than the classifier did. And just to wrap up, so the developments in the web as we've moved from mainly professionally produced text to much more interactive behavior on the web has created challenges for computational linguists, but also opportunities. Right, we can look into ongoing conversations between people in the general public. Trying to predict political orientation just from the language that posters use is not as successful as we might like. So using things like PMI-IR or naive Bayes, which have been very successful in other domains, don't work nearly as well at predicting semantic or political orientation. right? And I've talked about some reasons why that's the case. But bringing in information from the structure of the community, kind of the stance, the role that people play in the ecosystem of the discussion group can augment the lexical content of their posts and give us better results, right? And I mentioned some directions that this is going on. I'm also looking at using statistical methods to extract issues, right? We can find out what are the issues that people are talking about, and then perhaps an inventory of issues could be used to classify people, right? Rather than looking at political orientation as a sentiment, we could look at it as a bundle of sentiments with respect to a bunch of issues that are being frequently talked about. All right, so any questions?
Well, every time I see PMI being used, I wonder if you know, I mean, you certainly know the comments
Sure.
Manning and Schütze make in their book about PMI being overwhelmed by the frequency of one term.
Yeah.
How to counterbalance that. Is that a problem for that application or not? Did you try other measures, or did Peter Turney try other measures and find that PMI works best? Or?
No. My own experience has been that PMI works best for this kind of stuff.
Better than, for example?
Chi-square, for instance. You have to be careful with it. So I throw out any term that occurs fewer than 5 times. And not for Turney's method, because I was trying to reproduce what he did as closely as possible, but for that little lexical discovery task where I was looking for terms that were associated with orientations, I weighted the mutual information by the frequency of the term. And just in my experience, it seems to give very good results. I haven't really had much trouble with outliers, overwhelming things.
Yeah. But you only had a cutoff from below, not from above.
Not from above, yeah. But if I remember right, actually, I filtered out stop words for the lexical identification task. For Turney's method, since I'm looking at noun phrases, not individual nouns, the frequencies tend to be sort of middle. We don't make things very overwhelmingly frequent. Looking at the output, it sort of makes sense, right? There isn't really crazy stuff showing up as being strongly associated with liberal, right? The top terms are all, well, things that contain the term liberal most of the time, right?
Yeah. And the other question I had is, did you try to use, well, if I do text classification, I would first try the standard SVM light approach with linked features and text features, just as it's done.
Yeah. Yes, I did try that, and I got slightly worse results than naive Bayes. And I bet if I spent a couple of weeks working on it, I could make it better than naive Bayes. But for the purposes of these experiments, it wasn't worth the trouble. But yeah,
But isn't it the same kinds of features? So you have the links and the words, and here you use the links for clustering and the words for naive Bayes, and just throwing them into one model. Shouldn't that work better?
I didn't try that, perhaps. Yeah, that'll be something I'll have to try.
Is there any evidence, do you have any evidence that using more than one set of features can help? For example, citation and something else.
You mean including the citations in the classification model? I don't have any evidence that would help. I don't have any strong evidence that it wouldn't help. Yeah.
Can you tell us about the pharmaceutical application? Did you get the same results? On what was the classification task?
So there, I'm not doing so much classification as actually doing support for market researchers. And so in that case, we don't have the real answers, right? We don't know whether users actually, what their disease status actually is. Right? So for that kind of work, more of what I'm doing is a kind of word association thing, looking for associations between pairs of words, trying to build high precision classifiers that can pull out a bunch of posts from people who are newly diagnosed, right, that then a marketer can read over. It's not necessarily an exhaustive list. That's much more pragmatic stuff, which is very, very hard to evaluate. I mean, there the evaluation is, are the marketing guys happy with the output of it? Can they look at these graphs and draw some conclusions that help them? And so for that kind of an application, whether I shouldn't say this, but whether the results are actually true or not is not nearly as important as whether they're useful for spurring creative ideas. Right? And so the evaluation is much more informal and much more, is this useful? Right? So that's one reason why I haven't published any of that stuff. Right? It doesn't fit into kind of what computational linguists do, although it's what marketers need. Right? It would be nice to be able to evaluate it, but given that we don't often know very much about who these people are who are posting, it's difficult to do.
So it's not a classification in potential customers?
Right. No.
Okay.
No, it's more like, well, things like what are the concerns that newly diagnosed patients have,
Yeah.
right? And so, for instance, for one medication, I found that what the risks were in pregnancy was something that people came to sites to ask about a lot, right? So that was an issue, and that was an important thing that people were talking about, and that was something that the company could address by making a pamphlet about that to deliver to doctors. Right?
No more questions? Okay, thank you.